This is the first in a series of videos to give you the capability to use Google Sheets as a really nice computational tool. We're going to get into modeling and also building simulations using Google Sheets. But today, this video will handle really just doing some data analysis. Okay, now my suggestion is before you go any further, go and go to File and make a copy so that you take my spreadsheet. If you just if you just have opened this spreadsheet, you can't do anything on it. You don't have editing privileges. So if you make a copy, it will be yours in your file, and there you can follow along, do things. Okay, you can do the calculations, you can do the graphing when we get to that. All right, and it'll save in your account. Okay, so let's go look at some data that we're going to manipulate today. So go to the data. All right, so we've got some three different mass materials where we measure the mass of the three materials A, B, and C, where we had a set of volumes. This could have been metal. It could be three metals that were cut such that this was the volume, and if we did this very carefully, we cut the same length very consistently into three metals. Another way might be melting the metals and pouring them into a precision-made die, and so we can have some faith on the volumes. Anyway, we measured mass at these volumes for these three materials. I want to calculate the density from each determination, and then I'm going to do some averaging and calculate a few things down the bottom. Okay, so I want to go up to the column density for substance A, and what I want to do is I want to take this mass and divide it by that volume. And so to do any computation in any spreadsheet, start with an equal sign. The equal sign throws it into a computation mode. Otherwise, it's reading things in there as text, and you won't get your calculation. Okay, so I'm going to go over here and click on the mass. Then I'm going to push the slash for divide and click on the volume. You'll notice I'll get these things colored to show me what I just did. So I've got the mass over the volume. That'll give me the density. I will actually hit enter to go out of that cell. Okay, and right away Google asks if you want to autofill. Now the problem here is it autofills all the way down, and it's reading this. It doesn't know that's words, so it's saying, well, I can't do that calculation. Okay, so I'm going to nix the autofill this time. Autofill is really great if you had 1,000 calculations. I don't want to drag that down. If you go over on the corner here and drag down, okay, you'll get the densities calculated. Okay, now I want to go over here and I want to do the same thing, but I'm going to do this much easier. I'm going to go in here on this cell, and right now whenever you have just a bare cell reference, you have what are called relative cell references, so that if I drag down, what this will do, if you go down here to row 8, you will see I'm dividing B8 by A8. Down here, I'm dividing whatever that was, B16 by A16. What I'd like to do is take this formula and I want to drag it over and then just drag it down. And if I go up here and I keep the a column with a $sign, I have what's called a partial absolute reference. You'll see absolute references later, okay? And what that'll allow me to do is if I drag over, it will correct the formula to take, and if you go up here and click on the formula bar, it'll now take the mass of B divided by the volume, okay? And if I drag that over again, first I need to enter and get it. If I drag that over again, it will take the mass of C and divide it by that. If I highlight both these columns and now drag down, it will fill out the rest of the calculation. Okay, so the only reason I didn't use the auto fill is because I've got calculations down here. Okay, so there's some basic things. Manipulating, doing some very simple computations on data. It can be unit conversions. It could be you have to make some kind of conversion before you use the data for your calculation, and it can be more involved than just density. Okay, all right. So down here, I want to get an average. Okay, now Google is loaded with functions, and up here now also Google tries to be smart and figure out, well, what do you want to do? And I'll tell you about half the time it gets it. Okay, it doesn't get it all the time, but it wants to take the column of data from E5 to E19 and calculate the average. How did it guess on average? It actually sees the word over there, so it knows what to do. If you didn't know, you could go into the function list. Here are common functions used, and then you can go and look up functions, and you can get a little information. The other thing you can do in Google is if you go to help, which we're in the middle of a calculation, so it won't do that. Okay, but I'm going to accept that calculation, okay, and it'll calculate the average for me. And then what I'm going to do is I want to drag this over, so I'm going to go in and I'm going to fix that. And actually, I want this to do the next column, so I'm going to drag it over, and it will switch and do that column, and then drag it over again, and it will do that column when it finally makes up its mind. I must have not caught the corner right. Get the corner. Oh, come on, Google. All right, there we've got our three means, and if you go in here and check, it's using the column D data. Okay, now range, if you put that in there and see what Google will tell you what it is, it doesn't know what a range is, but we can get the range by using the max function on the data, and it's already smart enough to know that that's what I want. Minus, I messed that up by not getting outside. I want to get outside of that. I don't want it to calculate the max yet, but it's getting ornery on me. Okay, so I'll actually let it calculate the max. Then I'm going to go in there and I'm going to alter that formula by going minus the min function. And is it bright enough? It actually wants to use that, and that's okay with me. I don't know why it didn't use what it's highlighted, but we'll highlight that thing again. Okay, and then hit that. All right, and so what you now have is you have E5, E19, first get the max, then get the min, and subtract. That gives you the range. If I drag that over, it'll give me the range for those two. The range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range is kind of a poor man's estimate of, the range the imprecision. If this is all material A, then if everything was perfect, we should have got the same density on all the trials. But we got a little bit of variation. This is a quick way. The quick thing about it is in this column of numbers, if you were just looking at that, you could find the max and the min. Okay, it's not a very helpful thing if you have 1,000, but you can always go to the bottom of the column and calculate it. Let's get a better feel on variation and do the standard deviation. Here we'll put STDEV. Okay, now standard deviation, there are a number. The one that you will most commonly use is the first one, okay, which will calculate the standard deviation based on assuming that this is a sample out of a population of items, and we always do the sample. If we hit enter, it's going to calculate that. And once again, I'm going to hit enter again to put the formula in there. It calculated that. I'm now going to drag this over. Okay, and now I have the standard deviation. Okay, now if you use range, the density column that has the most variation looks like C. If you use standard deviation, it looks like C wins again. But now we're going to calculate the coefficient of variation, and you'll notice up in the cell where it's %CV, there is a little black triangle, okay, and that means there is a note, okay. Tells you what this is coefficient of variation. It's the standard deviation divided by the mean, and it is also a measure of precision as our range, which is crude. Standard deviation has a problem in that the standard deviation is not a good measure of precision if the means are different. Since we have different means, what we want to do here is we want to take the standard deviation, multiply it, so we use the asterisk, by 100, and divide it by the mean. Okay, and so we have a variation here of about 10%. If we swing these guys over, okay, now notice the most variation in the data is not in sample C, it is actually in material B. Okay, so the coefficient of variation is a better way of looking at precision or variation. Okay. And so there's a nice set of calculations, okay? We've calculated an average, a range, a standard deviation, and we've added the coefficient of variation, okay? And again, this one you have to do yourself, all right? All right, so I'm going to end the video here. I'm going to preview the next one. We're going to go and we're going to plot this information. We're actually going to do a mass versus volume plot. But I'm going to do that in the next video, so I'll see you short. Keep your spreadsheet handy because we'll do it right here where you've done the calculations. All right, let me wake up the computer here and say stop. Yeah, the new fully good captain, I hope not.